Hello and welcome to Maths 9. Okay, I'm going to be trying using a black pen for a while. It might just be a little bit better for kind of maths and stuff like that. Okay, so we're going to move into a different topic now, and the topic is going to be exponents. So we've done a lot of stuff on fractions. Um, Talked about the real numbers, integers, natural numbers, irrational numbers. We spoke about bounding as well. So let's think about exponents, and integer exponents is a good way to look at it as we move forward towards this kind of just algebra really. All right, so any number can be simplified when you're multiplying. So say we do 3 times 3 times 3 times 3. That's going to be simplified simply by doing a superscript up here, 3 to the 4. So what's that? 9, 27, 81. So we can put that there. And that's a way to shorten how long, how many numbers you have to write. Um, so yeah, so if any real number a, and then we can write exactly how this looks. So it's going to be a times a times a times a dot dot dot, and there'll be an a at the end there. So however many we've got, we don't really know how many we've got. I might just, yeah, I'm going to just do things slightly differently here. I think I'm just going to do sort of like a straight line and a diagonal thing there. There's no real need to do this kind of rotated curly brace here. Well, giant rotated curly brace, I suppose you could call it. But yeah, I'm just going to do a simple line with some diagonal ends there. But so for any real number 8, we could see there's n equal factors, all of which happen to be a. And this will give us a to the n. Okay, so this a is known as the base. And the n is the integer exponent can also be called the power, and it's a superscript. So they're all things which are covered. Okay. Now, just a brief point. So a to the 0 is going to be 1. This is, of course, assuming that a is not equal to 0. And this is because 0 to the 0 is undefined. Okay. So any number to the 0 power will be 1. So we can take 5 to the 0 equals 1. We can take minus 100 to the 0 is 1. And so on. So, yeah. And if we look at the early powers we deal with, so a to the 1, a, and that's going to be a to the first power. So you could have, you could do 3 to the 0 is 1, 3 to the 1 is 3. That's how it works, basically. It'll be the same. So 5 to 0 is 1, 5 to the 1 is 5. That's how that works. We've got a squared. This is a times a. So it can be said in two ways: a to the second power. It can also be said a squared. That's because if we have an area here, a times a, then this shaded area is going to be a times a. So the area is a squared. With a to the 3, we'll say a times a times a. So 3 of those, and this can be said a to the third power and that's going to be a cubed. Okay, and we can see similarly the geometric form for that. So if we just draw the cube, we can see again we're going to have length and the breadth, and then we can see the height is going to be this area, this spot here, isn't it? And we can see if we multiply them all together, we're going to get the volume. So the volume equals a cubed in for this particular cube. That'll be any cube. Well, okay, so yeah, so in general, anyway, dealing with a to the n will simply be a times a times a times however many a's. Let's try and get into the habit of doing it like that, because doing the curly lines, it just makes things seem messy. Even though it's kind of what I've always done, but you know, I think the less messy things are, the better. Really, it's the way you've got to look at things. Well, no, it's the way that I do anyway. All right, so that's so basically that would be a to the n power. So that's in cases where the early powers there are not enough. But yeah, there'll be n factors either way. Okay, so now we're going to consider. Yeah, I should always for maths videos put a bit longer, because I do tend to take up a lot more space. Because I just like everything to be a little bit clearer and less on the screen. Okay. So even powers and negative numbers. Let's do these then. You recall we also did in I think it was 7 or 6. Yeah, it was 7. We looked at implication. If a and b are odd natural numbers and a plus b is even, but it's only a one-way implication, because if a plus b is even, then a plus b could be odd, so it's not the other way. And similarly for x plus a equals b, we could say x equals b minus a, and because that's an equation, it's a two-way implication. So that was just something I said. I just wanted to mention it again. We'll just go back and watch episode 7 to get a good grip on that. So even powers and negative numbers. So let's do an example here. So if we do minus 3 to the 4th, what's that going to be? it's going to be 4 lots of -3, isn't it? So we're going to put that down here. Okay, so we can see what happens. -3 times -3 is 9. And then we take the other two -3s. That's also 9, so it's 81. So -3 to the 4th is 81. Okay, and the important thing to realize here, so this is not equal. This is not equal to this, -3 to the 4th. It looks the same. But we'll recall though that this power is much higher up the operation list in terms of importance than a simple minus. So what this goes to is, so that's going to take the 3 away, and it's going to put it inside its own bracket. So this is going to be this. Now here it's obviously easier to tell that that's different. So 3 to the 4th is 81. So that's -81. So you can see these give opposite results. So yeah, so they've got opposite results, those things. So that's important to note. Next thing we can talk about. Okay, so we need to think now about certain rules that we can create with regard to the operations. I spoke about operations, so let's actually just do that topic now. So operations rather with integer exponents. So we can see what sort of rules we can get to help us in get up to speed with basic algebra, and hopefully it will make it there. Okay, so if we had, so we've got this 3 to the 4th again, and we want to multiply it by 3 to the 4th. Well, we know for a fact what this is going to be. It's going to be 3 times 3 times 3 times 3, and then times 3 times 3 times 3 times 3. And we can see there's 8 factors here, equal factors. So that's going to be 3 to the 8th, 3 to the 8, 3 to the 8th power, as we okay, and obviously this will work in all cases, so we can write the rule. So let's write the rule. And that rule is going to be a to the m times a to the n equals a to the m plus n. Okay? And that's the same base. Now also, one thing I did yeah, and remember that the letters we're using, these are integer letters. Recall as well, constants is A, B, C generally, integers generally I, J, K, L, M, N, variables being X, Y, Z. So we're dealing with the integers, which are in the process of just in the process, I guess. Okay, so then we could say, for instance, that 3 to the 8 times 3 to the 15 going to be 3 to the 23. So we don't actually even need to do anything beyond that to get the answer. All we do is of course, we assume the same base. Always be the same base. So that's important. That's very important because it's not going to work otherwise. All right. So the next thing then is say we've got that 3 to the 8 again. We've got that 3 to the 8. And then we're going to put this box notation here, which is I really like that notation. I used it a lot. So 3 to the 8 times 3 to the box equals 1. So we know for a fact that that to get we know what 1 is in terms of the same base. We know that 1 is 3 to the 0, don't we? And we also know that if we add up m here, this is going to be basically like m, and this is like n. I won't put that in. If we add them up, then we're going to get what we want there. So we sort of know that. So we sort of know that it's kind of like. So it's sort of like 3, and then we got 8 plus this box is going to be 3 to the 0. All right. And then we can say, so then we say 8 plus the box is going to be 0. If we just take this this superscript line here, and there, so therefore this box is going to be minus 8. So we can then say that 3 to the 8 times 3 to the minus 8 equals 1. Okay, now if you recall back to fractions, there is also something else that I wanted to mention. Let me just mention it here actually, because it's kind of useful to have some of this on the same page here. If we wanted to get to 1, we remember that the reciprocals, when they multiply, that equal 1. So say you have so in most cases, like half times 2 is 1, third times 3 is 1. So we saw that occurs, right? So what we can say is, let me do a simpler version just to get it kind of clear. And let's say we have, let's just do 2 squared. Let's see how we can get from 2 squared, and we want to get to 1. So we're going to do 2 squared times 2 to some power, and we want to get equal to 1. Okay, so we know, right, that this is going to be, so we know from what we've done here, this is going to be 2 plus box equals the 0 here. Because we know that we know this as well, right? The 2 to the 0 equals 1. So we can then say that the box is going to be minus 2. So we can say this is 4. And then what this is going to be actually the reciprocal. So the reciprocal of 4 is 1 over 4. So that's always going to be the case, that we're going to have the reciprocal there. So in the case of 3 to the 8 and 3 to, it's basically what we're saying here is we're saying 3 to the 8 times 1 over 3 to the 8 equals 1. So this multiplication is always going to get us 1, and that's a key point here. Let's see. Okay, so I think I'm going to leave it there. I'm going to be doing a lot more of this in the next episode. I just wanted to do a small intro there, and just to do one example that kind of linked in with what we were been doing previously. Coming up, though, we're going to look more at negative exponents, more understanding, what it means to be the base, more rules, because we can get a few more rules out of this as well, which I haven't talked about yet. So that will be coming up over the next few episodes, and then of course we'll consolidate it in episode 12. So until then, thanks for watching.